solving inequalities. Remember, an inequality is a number sentence that has a greater than or less than sign, or in this case this is a less than or equal to. So it's saying that some number plus 3 is less than or equal to 24. So this could equal 24, or it could equal 23, 22, etc., going all the way on to infinity in the negatives. The biggest mistake people make is they think there's some weird trick or something to this, and there's really not. It's the same solving that we did with our equations. I want to isolate my x. The way I isolate it is adding the opposite of the 3 to both sides of the inequality. I still have x over here. This is 21. The only difference with this and my equations is that in an inequality you just keep the same sign. Okay, so I just have that sign, bring it straight down, keep it there. So the answer to my inequality is x is less than or equal to 21. So x could be 21, it could be 20, it could be 19, etc. That means that any of those values for x, if I plug them in up here, would work. Okay, so x could be 21. If I plug it up here, 21 plus 3 is 24, which works because it can be equal to 24. It could be 20. 20 plus 3, that is 23, which is less than 24. It could be a half, right? That's less than 21. A half plus 3 is 3.5, also less than 24. So that is our solution. X doesn't equal just one thing, it equals a whole range of numbers, and we're trying to figure out what that range is. Often they'll say solve, then graph. So there's solving. Next would be graphing. First of all, one common mistake people make is they try to graph before they solve. There's no way you can graph before you solve. So you solve, you get this as your answer, and that's what we're going to graph. So you draw a number line, and what makes sense is to try and put that number in the middle. You'll see why that makes sense to do that. And just give it a couple on either side. Oh, what am I doing? 20, 19, 18. So 21's in the middle. And I want to graph this. So graphing is basically showing in a sort of a picture way, an illustrated way, what this means. So what this means is that x can be 21, right? So if x can be 21, I'm going to go ahead and put a dot on 21, and I'm going to fill it in, because if I fill it in, that's saying, yes, it can equal 21. That's representing that little line. And then x can also be anything less than 21. So where are all the things less than 21? That way, 20, 19, etc. But it's not just these numbers, so I don't want to just put dots on them. It's everything in between, right? So I'm going to put a solid line going all the way this direction and put an arrow showing that it just keeps on going. Okay? So I have a solid dot on 21 because it can equal 21. And then I have a line with an arrow going all the way down to represent all of the numbers that are 21 or less. So that's graphing your solution. All right, let's look at another one. So just like with my equations, I'm going to solve this one the same way. I'm going to isolate my x by multiplying by 1 over 3. So that will cancel those out to 1. And we'll multiply this side by 1 over 3. So I have x left on this side. Keep my same inequality symbol. And this is 11/3. Okay? So there's my solution. I've solved my equation. And now I want to graph. Now, since I'm using a number line, something that might help me in this case is to maybe turn this to a mixed number. It's up to you. Because if I have my graph, what is 11/3? Like I have 11/3, 12/3, etc. It's good to understand what that is. So that's the same thing as 3 2/3, right? So if I have the number 3, and then over here I have the number 4 and 5, down here 2 and 1. Where is 3 2/3? So I'd have to split this up into thirds. There'd be 1/3, 2/3. So right there is my 3 2/3. Okay? Another way to think about it is if we went all the way down to 0 and you did your graph by thirds, I'd have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3. So there's that 11/3 right there. 3 2/3, same thing as 11/3 if you're counting by thirds. All right, so now I want to, I have my number line. I actually want to draw out my graph. So I have x is greater than that 11/3, or that 3 2/3, okay? Now, it can't equal the 3 2/3. So the big question is, where do you put the dot? Do you just put it on the next number, 4? But what about all these little fractions in between 3 2/3 and 4? So the way you show that we're starting at 3 2/3, but there's no equal, it can't equal it, is you put an open dot. You see on the last one we had a solid filled in dot because x could be 21. So we wanted to show that. So we put a solid dot there to say, hey, we're starting at 21, and then we keep on going. Well, this time we're starting at 3 2/3, but I don't want to include 3 2/3. So that open dot is telling me where I'm starting, but it's indicating that I'm not including that as one of the answers. So then I go from there, and I say x is also anything greater. Greater is always going to be to the right, 4, 5, etc. So it's everything to the right, and all the fractions in between. And it keeps on going for forever, so I'm going to do an arrow. So the only thing with the graphic is you got to decide, am I doing a solid dot or an open dot? A solid dot goes when you have the equal sign underneath. So one of those symbols or one of those symbols is a solid dot. The open dot goes when you don't have a line. So greater than or less than with no line would be an open dot. So that's the difference between the different kinds of dots.